Next one up is actually Niels, who will be talking about open source meta catalogs. There you go.
Thanks, Pascal. Yeah, so Niels, this is me. Pascal asked a couple of months ago, okay, we want to do some talks on the state of data. What has been trending last year? One of the things, of course, was Gen AI, so he picked that, and then I was left with what is the other trending thing to talk about, and that's data catalogs. So, unless you've been living under a rock, you probably have noticed quite a lot of buzz being created online about data catalogs, and it all started with these two. Both Snowflake and Databricks, they open sourced their data catalog called Polaris and Unity catalog. And this created, of course, some buzz with people discussing again which is best, a bit like what has happened before between Spark and Databricks and Snowflake. And in the end of last year, there were quite a lot of query engines saying that, oh, we have integration with these metadata catalogs. So this means that there is a lot of talk about it, but I also noticed that quite a lot of people, they don't really understand what is happening here, when should you use them. That's why I want to create this talk. And starting point is, what are data catalogs? And I've compiled here a small list, well, I took it from another site, of every product that calls themselves a data catalog. There are quite a lot of them, and not surprisingly, their definition of what a data catalog should be is very different. And that makes it quite confusing because depending on what you're used to, it might be comparable to another tool or not. So for the purpose of this presentation, I will make a distinction between two different situations. On one side, you have the technical data catalogs, and the focus of these technical data catalogs is mainly to assist the query engine in performing their task to query your data. These ones are often also referred to as metastores. And this comes back to the original metastore that existed, which was called the Hive metastore back in the days when Hadoop was popular. This was the first catalog that was created. So this is very different from, let's say, the other trend where it's more business-oriented catalogs, which are more focused on data governance. Examples here are Colibra, or Data Hub, also our product portal could maybe fit in here. And the focus here is much more on adding some governance features. It's about adding data quality, data lineage, making your data discoverable within your organization. So today I'm going to talk about these technical catalogs, and I will use the word metastore or data catalog interchangeably, but always in this focus. Okay? So in order to understand what a metastore does, it's maybe good to look back at the first version, the Hive metastore. And we go back 15 years, 2010 was about the time when it was released. And why was this needed? So we had the big shift of a central data warehouse which stored all our data to do our analytical queries on. We moved towards a more data lake architecture. And why did we want that? Well, we wanted to decouple our storage from our compute, which would allow to have different computer engines to process the same data, and the data we just store on flat files, on blob storage in S3 or whatever. Now, since we were always used to have SQL tables, we would like this SQL semantics to still exist within these data lakes. So what did we do? Well, we create a small abstraction and we create a table in Hive metastore. And what did the table consist? It said, okay, we have a schema here for my orders table. These are the fields. And the data is located on this path in S3. Very simple. So if a query engine, if you would ask, okay, give me the data of the orders of last month, then the query engine would ask the metastore, orders, where can I find this data? And I'm looking for this month, so give me the relevant files. So the Hive metastore, it says, okay, I have a list of all the files that are relevant. If you did a great partitioning, it knows this Hive partitioning format, and then it says, for this month, these are the relevant Parquet files. It gives it back, and then your query engine says, I can query all the relevant data in Parquet, in Avro, whatever file format that you use. And you could say, okay, this is all good and well, then why are you talking about this? Unfortunately, there were quite some problems with this initial implementation of our table abstraction. And the major problem that actually existed is that it's quite a leaky table abstraction. And why leaky, I will explain in more detail. So the leakiness comes from the fact that, well, we came to expect certain characteristics with SQL tables. One of the characteristics we're used to is asset semantics. So a lot of people who started using these tables with Hive, they assumed that, well, if we're updating our table, it's always atomic. Either it's fully completed or not. Unfortunately, in our setup that we have at that point, this is not the case. Another problem is if you want to change your schema. Well, you want to drop a table, you want to rename, you drop a column, you want to rename a column. We expect that this just works. Unfortunately, within the Hive system, this led to quite some issues, and people who have been there were quite a lot of problems with it. And then lastly, also performance was often an issue. And why was this often an issue? When you queried it, I told you that Hive has this Hive partitioning. That's how they partition, how these files are stored in your blob storage. And with using this Hive partitioning, you could filter which files are relevant. So if you have a good Hive partitioning scheme, which is typically, well, in a lot of cases, this year, month, day, if you have data coming in every day, then you could filter quite efficiently. But what if your query doesn't use any of those? Well, then the performance was terrible, because you basically did get all the files back and your query engine queried all the files. So as your data increased, your performance go down. So that's problematic. So they said, okay, we need to do better. And so what did we introduce? Well, we introduced table formats. You had Delta, you have Iceberg being introduced, Hoodie. These table formats, they put again these table SQL semantics as a first-class citizen. They solved a lot of the problems, the schema evolution part they solved. They now, next to storing all your data in Parquet or in Avro, they have also stored some metadata about which data is on all these files, which they can use to query it efficiently. So if you query on another field than your partitioning and then your files are stored, it can still prune certain files which have no relevant data there. So this is a great improvement. Now, my talk is not about table formats, so you might wonder, okay, why do you still need a metastore if these table formats solved all of your problems? Unfortunately, they didn't solve all of the problems. So if you're using Iceberg, you need a metastore in order to have asset compliance. So Iceberg relies on a metastore to store basically the pointer of what is the latest snapshot of my table in a reliant way. So if you're using Iceberg, you need one, but then if you're not using Iceberg, what additional benefits can these metastores provide? And one of the key things I think is very interesting of this metastore is they could centralize how we provide access towards the data. This has been, well, it's certainly in the beginning when I started, quite neglected, let's say. Basically, it's an S3 pod, and every engineer in the team have access to it, all the products have access to it. Now, lately, this has changed, of course. We are more concerned about who has access to which projects and which data. Now, the problem comes that, well, we have stored this data in multiple places. We may be using some S3 pods for one data, but we also store some parts in Snowflake, some parts somewhere else. So we need to have these access permissions spread out in all these different systems. Now, if you have a central catalog, it could be the central place where you provide access and you solve it that way, and that you don't have to put it on every of the underlying systems. And I will talk a bit about more how to do that later. Another benefit of these metastores could be that they provide an abstraction on top of the different table formats you use. Now there is often the debate, should I use Iceberg, should I use Delta, should I use Hoodie, what is best in which use case? And a metastore could say, well, we integrate with all of them, and it doesn't matter for us how you wrote them, we can provide APIs to query them whatever format you want. And this is possible because while your data might be very big for a table, that metadata that is stored by these table formats is a lot smaller. That's, for example, what the Unity catalog does. They say, okay, you can query using Iceberg or Delta tables, and we transform them for you such that they are compatible. Okay, so now we have some use cases why these metastores are useful. Let's dive into the differences between the two. First of all, the Unity catalog. It's been created by Databricks. It's multi-cloud, of course. Confusingly, I think for a lot of us, is there are two versions of it. A bit like the typical Databricks fashion, you have an open source version and you have their own managed version. And the feature set is not the same. Hopefully, Databricks will incorporate all the features that they now have in their closed source solution also in open source, but at the moment there is quite a big difference. So if you are looking at the Unity catalog and you want to use the open source version, host it your own, make sure that you check whether it's the open source Unity catalog that is supported or not. If you look at query engines, which query engines integrate natively with the Unity catalog, the list is not that long yet, but it is increasingly quite quickly. So it might be that my list is already out of date. I didn't do an extensive search on everything that is supported. But the query engines are limited, but the file formats are quite extensive. I told you that the Unity catalog has support for all the table formats. So they support Iceberg, Delta, Hoodie, and all the other file formats that you typically see within data engineering. So in that sense, it's a very complete system. It's mainly the query engines where you need to look for whether what you are using can integrate with this tool. On the other hand, you have Polaris. And Polaris is an Apache project. It's also multi-cloud. And it's not, well, it is actually an implementation of the Iceberg REST API. I will not go into detail about what this means because it's a very deep technical thing and I only have 50 minutes to talk about this. But yeah, this means basically as a good thing that any query engine that supports Iceberg integrates already with Polaris because they implement just the specification of Iceberg. And I told you that Iceberg relies on this metastore in order to provide asset semantics. So they have a specification how such a metastore must be implemented. Polaris implements it, so they are compatible. This means that a lot of query engines fit this bill. The downside is, since it's tied to Iceberg, the file formats that you can use are limited to just Iceberg. This is already a big distinction between the two and might change whether you should use one or the other. Now, what are the three interesting aspects about why you should keep track of these metastores? First thing, what I really like about this is that they focus on the open source. And this is completely different than 20 years ago, where every vendor creating their data warehouse created their own custom closed source solution in their proprietary formats. I really like that these two vendors, they decided to open source their solutions and share them with the community. This also means that the community, luckily, also the community adopted them quite quickly, and there's becoming a lot of support from these query engines to integrate with them. The second thing is one of the key aspects, in my opinion, is that they are a way to provide access to your data in a centralized manner. So how does this work? They both have this credential vending mechanism, and it's quite simple. So you have your metastore, you have all your tables there, and you say which project have access to which types of data. Then if a project says, I want to query certain data, it says, yes, you can query, the table is there, or you should look at these files on blob storage, and you get a temporary credential for accessing that data. And this is really crucial because without that, this credential mechanism, you should provide access in the metastore to give access to that tables, and you should also give access to the data in order to query that. So this credential vending is a really neat way to have one place where you provide access to your data and make sure that your applications can still run. And then lastly, the adoption has been quite quick. It has been released in June last year, and we see already a lot of open source projects integrating with them. Two examples of two products that I'm fond of, DuckDB and Polaris. They announced end of last year already basic support for these metastores. It's not full support yet, it's often read-only support, or they don't support fully the credential vending mechanism yet, but this adoption will go quickly. I project in the next year that they will be fully integrated or fully supporting both of these metastores. So, where are we now? Should you look into that? Are they a replacement for the Hive Metastore? That's actually the first question, because at the moment the Hive Metastore is used in a lot of places. In a lot of data engineering, if you're using Spark, if you're using basic Databricks without the Unity catalog, it uses the Hive Metastore underneath. So will we be able to replace it? Well, in a sense, yes, because the new Metastores, both Unity catalog and Polaris, they have more features and they support the same functionality. On the other hand, not all query engines support them, so it might take a while before you can use them. And well, since the Hive Metastore has been around for 15 years and these Metastores only for half a year, it's maybe not ready for production yet. But it is worthwhile to investigate. Now, who should care about this? You might wonder, okay, I'm a data engineer, should I actually care about these Metastores, these features? If you are a data engineer working on use cases or you're an analytics engineer, I think you should not care too much. The high-level idea of why are these Metastores here, what are they used for, high-level picture is good enough. Because most of the technical details should be hidden. A bit like the Hive Metastore, probably for a lot of you was not a technical thing you were thinking about. Maybe your data platform team said, you need to put these two settings in your Spark config in order to make it work, and you thought, yeah, this is magically working good. I don't need to think about this further. As a platform engineer, though, this is something you should investigate, you should look into, you should compare what can we use, and you could see whether it could benefit you on the long term. I talked about these access permissions. This is, I think, the key point of integrating them. And that's one of the capabilities that a lot of data platforms are looking into and are trying to provide. And that comes back a bit to what Johnny's talk yesterday did on looking which capabilities, which self-service capabilities do you want to include in your organization. And I think these Metastores can be a good fit for that. So that was all I wanted to talk about. Are there any questions? Yes, Gergen.
Yes, I'm actually very curious about this credential vending mechanism because I guess that it has to be implementation specific, right? So either AWS or Azure or whatever, right?
Yes.
So do they implement at least a couple of these systems, or how should I imagine that?
Yeah, they implement a couple of systems, I probably not all of them, but indeed in a couple of systems it's implemented, and typically the SaaS version, if you use the Unity catalog, it has quite extensive integrations with, if you run it on Azure, of course Azure Blob Storage is supported. If you run it on AWS, I'm not sure about all the integrations that exist, but that's indeed, it's implementation specific, yeah,
because
correct.
It simplifies a lot, right? Because
Yeah.
normally you have to specify, let's say, on AWS group permissions, but also S3 permissions.
Yes.
Here you have to only say, hey, Unity, whichever thing.
Yeah.
And go, right?
Yeah. Yeah, it could be the central point where you manage your permissions, and if you then configure it correctly, you have for the rest, not for every project, assign the right permissions on different prefixes, etc. Yeah.
Neat. Thanks.
Anybody else? All right. Johnny, yes?
You have this whole stack of many different technologies
Yeah.
on this multi-level diagram that you showed. When would you advise to go with this approach, or when would you advise against going for a proprietary solution? Because I can imagine these components, they all need extra knowledge, they all need extra maintenance. How do you decide?
Yeah. Well, it's a good question. How do you decide on whether you should use all these different types of layers and implement them, or whether you should go for a simpler solution? Well, it depends really on your use case and what you need, of course. And what I think in a lot of ways, if you go with the open source solutions that exist and you want to be flexible, the basic lower level part of the stack is quite common. It gives you a lot of ways out. Of course, these Metastores, they provide extra functionality, but they also tie you to one specific. Whether you should use this or a closed vendor approach, I would always look at what are my escape hatches. Does this closed vendor support everything I need? And how easily would it be to migrate out of it if they, for example, if we want to switch at some point? With these solutions, well, switching from one to the other is quite common and is well known. A lot of people do it. For closed vendors, if they use proprietary formats, it becomes almost impossible to get out of it. So I would always look at how could I get out of it if at some point it needed, and then does it solve all my capabilities, or do I need to build something extensible myself?
Yeah, because this feels a bit like we started with data lake at some point because we need ML use cases, images, and which we had like 20 years ago,
Yes.
but on a larger scale, of course.
Yes.
While data warehouses have also evolved on that scale, they're also scalable these days. So I'm having difficulty, like, which one should I use with low operational costs?
Yeah, well, I think one of the key values of going the data lake approach is that you decouple your storage from your computer. If you use a proprietary vendor, well, you store all the data with them, and you can only use that compute engine, which is, well, typically cost quite a lot. Well, if you go in the Oracle days, those were quite expensive. Now you have cheap storage, and you can choose which query engine do you use. Do you want to use Spark for some use cases? Do you want to use Polaris for another use case? The data is still accessible for any of them. So I think that's one of the key points of going towards that approach. Is that always the right way? No, it depends really on the use case, but yeah. Okay. Yeah, Robert?
Yeah, now that we're on this slide, I think maybe the fourth bullet point would be the creation of views. I don't know if these table formats,
Yeah?
I get that they're like stored in these files in these file formats like Parquet or Ruby or whatever. But like a view, would that be like would the catalog also be a place to store a view?
I'm thinking whether that would be the place. I will think about it and I will come back to you. All right, then I will pass on the word to Jelle, who will give the next talk about data contracts.